You're watching the New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show.
NGINX, a part of F5, is the company behind the popular open source project of the same name. NGINX offers a comprehensive suite of technologies to help develop and deliver modern applications, including NGINX Plus for efficient load balancing, NGINX App Protection for enhanced security, and NGINX Ingress Control for fast, reliable, and secure Kubernetes connectivity.
Hi, I'm B. Cameron Gain of RevCom, and I'm here with the New Stack in Bilbao, Spain at the Open Source Summit. And I'm speaking with Liam Crilly of Engine. And I believe you're a product manager there.
Yes, I am.
And am I getting, we had a discussion about the name. Some people say Nginx, but it's Engine, is that right?
It's NGINX.
NGINX.
It's like engine,
right?
X.
NGINX.
Yep.
I love it. And how did that come about?
Well, because it was, the origin story is because the Igor Sissoyev, who was the original creator of NGINX, was building what he, at the time, he thought was a new web engine. He had been contributor to Apache web server, and he set out to solve a scaling challenge that it had at the time. And engine, new engine, NGINX, next generation. I'm not sure exactly, but it's a little bit too cryptic because it leaves people wondering, is it Nginx or something else? But it's officially NGINX.
NGINX. Well, we had this discussion before. We were talking over, well, you're eating lunch.
Right.
I haven't eaten my lunch yet, but we were talking about the how do you define WebAssembly, which is a big part of what you do, and you disagreed with my I guess definition, you could say. My perspective of WebAssembly is that I'm thinking of it as a developer might think about it, is you're doing your magic, you're doing your code, you're deploying your app, you're creating your applications, and you want to deploy through a Wasm module at once through maybe 100 or 1,000 different endpoints on whatever, on an edge device, on a web server, anywhere conceivable,
Right.
at the same time without having to reconfigure your code for each endpoint. You didn't completely agree with that. Why is that? Why was that the case?
Well, I think our disagreement was like, who is this really for? Is this for developers, or is this for in-production operations? And I think that's where I wasn't quite convinced with the way that you put it. I think I completely agree with the way you put it just now. And I think the long-term promise, the ultimate promise of WebAssembly is that you get to build this thing once. That's what's in it for developers. Build something once, run it anywhere. And there are some other advantages we can go into about what else WebAssembly can bring us. But for me, the number one thing is universal portability for my code.
And I thought it was really interesting what you talked about now, where you're confined a lot to the CPU instruction set for your application. And how will WebAssembly change that?
Well, maybe we should start at the beginning. So, like, what's WebAssembly?
In the beginning.
What's WebAssembly?
I thought we discussed that, but anyway, go ahead.
Well,
what is that?
What really is it? Like, it's a cool technology.
Yeah.
It's there's a classical definition for sure, but the way I think about it is that it's a new type of computer. Like, it's that fundamental. We've designed a computer, and what I mean is, like, it's got an instruction set like a CPU.
Yeah.
That's where the assembly part comes from. If you've seen like assembly code, it looks a lot like that if you make it human readable. And we've got a very simple computer that can do anything a computer can do, which we know is a lot. And what it means is we've got this new instruction set, very simple computer instruction set, that becomes a compilation target for all my programming languages. So take a high-level programming language, I can now compile it, not to the CPU instruction set of my particular hardware, I can compile it to the WebAssembly instruction set.
I've kind of got in trouble for this, but I once said a compilation or a compiler target on steroids.
I like that.
Some people don't.
The thing is, the cool thing about what WebAssembly does is that you get the benefits of a compiler, where you can take a high-level language and build really well-optimized instruction set code for it. But because WebAssembly is this abstracted computer, it requires a virtual machine, a runtime, to take this instruction set and actually run it on the hardware. And that sounds like an unfortunate abstraction layer, but the beauty of it is I can build a runtime for any hardware. And as a developer, I don't care about the hardware anymore. Actually, as an operator, I don't care about the hardware anymore. Because if I've got a Wasm module, as you said, that is something that I compiled to this instruction set, I have the benefits of the compiler and compiler optimizations, but I also have the learnings of the last, say, decade and a half of JavaScript in the browser to do just-in-time optimizations at runtime. As I'm converting the bytecode in this instruction set onto CPU instructions, I'm actually doing another level of optimization, which is the same sort of things that we see for the JIT compilers, runtimes, interpreters in browsers. So take that technology, add on compiler technology, and we get this additional benefit of like near-native compute performance. So there's very little downside actually at this abstraction layer.
But the JavaScript aspect you're talking about, that in this context is just germane to what's going on underneath the hood, right? I mean, whereas, as a developer, you eventually will be able to write your applications in any language. Rust is a popular one right now. Python is my favorite. Of course, C++, C, etc. And simultaneously as well, putting all these from different applications or code written in different languages together in the same module. But that JS aspect is what's running underneath the hood with Rust as well, I would imagine.
Well, I mentioned JavaScript because it's the evolution and the maturity of JavaScript and the performance of JavaScript is what enables the WebAssembly runtime to do this like last mile optimization on the instruction set. It's actually separate to WebAssembly itself. Now, and this actually brings up an important point. We've got WebAssembly is kind of bifurcated on where is this runtime. So you can build this runtime because it's a very simple computer, ultimately, WebAssembly, to run anywhere. And we've got the very popular runtime of web browsers, where I can write my WebAssembly application, have it run in a browser environment, and the browser is my runtime. It's what does that final conversion of the Wasm module, or I can run it server-side. That's
the hard part, in many ways, and that's what you're working on, I believe.
That's so...
Why is it so hard?
Well, it's, let's say it's immature rather than hard. So
that was the topic of your talk.
I did do a talk on why it's hard, or why particularly it was hard. The trials and tribulations that one of the teams I work on kind of went through to build to make server-side WebAssembly work. But I think if we're talking about maturity of WebAssembly, we need to always ask, like, are we talking about the client side in the browser, or are we talking about server side? Because if we're talking about in the browser, things are way more mature.
Yeah, of course. Yeah.
First of all, the browser vendors done a great job of building runtimes. The ecosystem, the environment, the constraints of where you're running are pretty well understood. It's a web browser, it's client side. It's what I used to do with JavaScript applications, and now I can compile to WebAssembly and they can run instead. And that comes back to your point about like the coexistence of JavaScript and WebAssembly. In the client side, these things now go hand in hand. But when we're talking about the server side, running it as the back end, an API endpoint, or I'm doing a microservices application, or whatever I'm doing, it's way less mature.
Yeah.
Like we have plenty of runtimes to choose from, but these are newer than the browsers, and more so, and this is what was part of my talk at WasmCon a couple of weeks back, is that the tool chain for not only building Wasm modules, but then how to run them, especially if we're building a web app, which is what we often building.
Okay.
That's not quite there yet.
Yeah.
And another dimension is the standards are not quite there yet.
No, certainly not. The famous component model, that's the big discussion.
Yeah.
How would you explain the component module to the folks out there who are just interested? They've heard about WebAssembly and they want to know what's holding it up.
That's probably the hardest question I'm going to answer this week. The component model is the vision by which we're going to make WebAssembly composable. That is, we think about a typical programming language. Let's take Node.js, right? We've got a library system. If I want to use someone else's component, you do npm, and I load it from that. If I'm doing Python's got its own thing, Ruby's got its own thing. All the languages each have their own ecosystem and toolchain for bringing in components. But with WebAssembly, we've got the possibility of bringing in components from any language, and that's another great benefit of WebAssembly, is that I can pick the best-in-class JSON library, right, whatever it is I need, and I'm going to get, it doesn't matter what language that was originally written in, I want to be able to consume it as a component. So that's one side of the component model, is that I'm going to be able to specify what things I need that I'm going to import into my component, and what things I'm going to, as a module, export to whatever other system I have. But the really nice thing about the component model is that it doesn't actually constrain itself to sort of the typical library ecosystem. Because for WebAssemblies to work, we need a runtime that it does that interpretation of the instruction set into the machine CPU hardware instruction set. And this runtime can also provide components. So if I want a key value store, right, I can import key val, and on one runtime I might get something very lightweight and naive, and in a cloud environment I might get something very sophisticated. And my runtime can provide that, or I can say I'm going to provide it with an import. And so the component model is this complete ecosystem, not just about libraries, imports, exports, but also about a choice of where each of these components is going to run from. That's why it's big.
I mean, I'm getting the impression that Wasm is there, but the component module is becoming a separate universe in itself, and that's it's a huge elephant in the room. But once that's finalized, or once the standard is finalized, then we're going to be able to see the realization of WebAssembly as it should be, or as it can be done.
Right. So we've got the beauty and the simplicity of WebAssembly is that this virtual machine, this instruction set, is as small as it needs to be and no bigger. The downside is, well, no one likes writing assembly very much. Well, some people do, but it's hard to be very productive. So far. But, and this is what the component model is going to bring us. It's going to bring us productivity. It's going to bring, I need this library. I'm either building an app or I'm building a library, and I got that capability. And if I'm building a runtime, I can say, oh, you know what? Wouldn't it be neat if my runtime provided a web server? And if I just need to import HTTP, I'll have a web server.
There's other aspects too. For example, the streaming aspect needs to be worked on a bit. And what are you working on? I mean, or are you actually working on things?
Yep. Again, we're Nginx.
Not you collectively, but you yourself.
So I work across a number of open source projects at Nginx. Of course, we've got the Nginx web server, reverse proxy load balancer that everyone knows and loves. We've also got another project called Unit, and that is less of a proxy and more of an application runtime. And so there's actually WebAssembly use cases in both of those projects. For the application runtime in Unit, we actually offer the ability to run the code. So we've got a WebAssembly module, we integrate with one of the runtimes, and you can very easily deploy WebAssembly server-side, whether it's for local dev or for a test environment, or you want to self-host.
Yeah.
You can now just have a small amount of JSON config, Wasm module, and you're good. And you can pull that as a container and run it.
And are you actually yourself developing these days, or contributing?
Those days are kind of behind me. So
yeah.
I'm as you said, I'm a product manager. I work, I look at making sort of long-term direction influences. I work very closely, on a daily basis with engineering teams. I do a lot of testing. I'm the guy that writes the Chrome demo app.
There you go. I mean, but I guess what I was getting at.
That's what I should have said, right? I write the dummy.
I guess I have a. I guess. I mean, what I was getting at was I just had this conversation before. It's kind of a question I have, personal question, is that how do you that aspect of where you're coding and working on these projects, and you're learning at the same time. You're using the command line. You're learning. You're practicing. You're coding. How do you incorporate that into your schedule, your development schedule? I mean, not your work schedule, or you're doing this at home. I don't know. How does that work?
I pick quiet times of the year.
Oh, just the year. Okay, you don't do it every day or every week?
I don't do it every. I like. I've been. It's coming up on 30 years since I wrote my first web application. I've been writing kind of rubbish web applications for a long time, and I've seen the evolution of the client-side and the server-side landscape.
Don't feel bad. I did HTML 30 years ago. So.
Yeah. Me too. I mean, I kind of find it helps keep on top of things if you just keep on layering your knowledge one top on the other, and that's why WebAssembly is so exciting, because actually it's positions us to propel how we build and deploy applications in a cloud world, and that's why I think developers should care.
Yeah,
is because this is now something that enables us to have a single build pipeline. We used to have a single build pipeline because everything was one CPU architecture and everything was one operating system. And in the current world, it's not like that. And we've got, on one hand, we've got the rise of like cloud IDE and like remote developer experience. That's a stretch for me, I'll be honest. I like to be, you asked the question, I do a lot on planes. I do a lot offline, quiet space when I don't have to take sort of regular product manager type meetings all the time.
Right.
So
I see.
And so for that, I can build it on my laptop, and I should take this Wasm module, and I should be able to run that on any cloud, on any web server, and that without building it again. And you might say containers are going to,
That's what I was getting ready to ask about.
So we got close, but containers are relatively heavy, like orders of magnitude larger in footprint. You have to choose your CPU architecture.
Yep.
And increasingly, like, if I want to run, most recently, I got a Apple Silicon MacBook, right? And I build containers there literally every day. And if I want to share something with someone, I'll use Google Cloud Run or someone else's container hosting service. But it doesn't work, because that's Intel. So now I have to build it again. With the emulation, so it takes forever to build my container, and I have to push it up, and then it works. And if I'm doing this, imagine this is my job. Now I have to imagine that's actually a real dev problem in production. I have to test that again. So this is what Wasm gives us. This gives us a single build, and it gives us one build pipeline for everywhere.
I didn't think of that, but I mean, you mentioned pipeline before, and the way you described it, I was thinking, I thought you were just limiting that scope when you said pipeline to the CPU structure. But in fact, I'm thinking this is good for the development pipeline.
This is CI/CD.
Yeah.
This is getting back to a build pipeline that is a few seconds long. Yeah,
wow, thanks. I really learned something from that.
And honestly, that's why the standards are so important.
Yeah.
Because until I can say, hey, this is a web app, and this needs a key val or a NoSQL interface, and I get that single build pipeline, so that it's the host system that's implementing the runtime itself that swaps that out for the one available in its environment, then that's when things are going to explode.
And I'm thinking too, people watching this might want to know, for example, you're working on a web server aspect mainly, but how would they get started? I mean, do you have a hello world type of application or access they could use?
Yep. So, yes, I work on the web server, so it's worth pointing out, because Nginx is so famous as being a web server, that's something that's coming.
Okay.
What we have in the Nginx unit project, so separate repos, separate code base, separate set of contributors.
Yeah.
That's application runtime, so that's much more appropriate right now, today,
okay.
WebAssembly. So if you want to get started on server-side WebAssembly, and you want to do it in Rust, because that's basically C or Rust is our current sort of SDK, then the Nginx unit project. So that's github.com/nginx/unit.
Okay.
And then you'll find that we have a hello world there for getting started. And of course, I have my rubbish demo app where I can.
I'm sure it's not.
We can find that too.
We'll see about that. I'll take a look.
Well, it's very simple, but it's a demo for a reason.
More than just hello world.
But you can. So let's put it this way. So Rust in hello world, compiled to Wasm. We're talking about 50-odd lines of Rust. If you want to build something, no, hello world's more like 20 lines. Something that, like a little microservice, that's more like 60 lines. So that gives you this sort of, and Rust is quite low level, so that's okay. And then when it's another like 10 lines of config, JSON block objects to configure it in Nginx unit.
And that's it. We're good to go.
Good to go. No other processes, no other intermediate layers. You don't need a reverse proxy. You can do TLS right there as well. So it's literally everything you need to deliver a server-side web app.
The documentation's there.
We have docs, we have SDK docs, and real soon we'll have some YouTube content as well on how to do that. And if you really want to see a rubbish demo, you can look up my talk from WasmCon a couple of weeks back.
I saw your talk, and it inspired me. And you said this is hard. At the same time, you're very candid about that and what.
Well, it was hard for the team.
Yeah.
And what we've got now is something which is a lot less hard.
Right.
But I'll say again, until we get the standards all the way there, it'll still be a little bit hard.
But what I try to go back to too is when speaking with engineers and developers in particular is that, again, going back to what we originally were talking about, is that maybe it's analogous to Kubernetes, where as a developer you shouldn't really, you don't really need to know the mechanisms of what's going on underneath the hood. You should just be able to do your work and deploy without worrying about it. But we're having this conversation right now because we're not there yet.
We're not there yet.
Yeah.
It's a different type of abstraction compared to Kubernetes, and the nice thing is it's completely compatible.
Yep.
So we're going to need to scale and automate and make these workloads resilient, and Kubernetes gives us a great place for that. I think there's a more interesting, more exciting future in what this can enable for a pure serverless abstraction experience, where we get away from the things we're used to with computers. We have this new computer, and it means hang on, do we need a file? Is that a useful thing anymore? That we just need? I either need structured storage, unstructured storage, or blob storage, or key valve storage. And now that we're past the 1970s, 80s sort of office, file system, filing cabinet metaphors, this is one of the other really exciting things about WebAssembly is it allows us to, this little computer allows us to rethink what are the abstractions we need as a society even. This allows us to take the next step forward rather than be continually sort of anchored back in these sort of initial primitives that we came up with to explain storage and compute. And that's why I mentioned it in the context of Kubernetes, because it still comes with that baggage.
I'd like to talk to you sometime, pick your brains about the storage aspect and disaster recovery, but at another time. We can go on for hours.
It is deep, yeah.
But the aspect of computing, I never thought of that. I never thought of it before. Second thing I've really learned today, speaking with you, thanks for that, is just thinking of it as a computer. And with a CPU. You have the CPU, you have the Wasm module, it's a computer.
We've got a little bit of memory, and that's all we got.
Wow, that is cool.
Yeah. And we can do a lot with it.
It's a computer. WebAssembly is a computer.
Yeah. Mind blowing, right?
Yeah, no, but seriously, yeah, really, sincerely. Wow. It's B. Cameron Gain of RevCom with the new stack in Bilbao, Spain at the Open Source Summit. And I'd like to thank Liam Crilly, a product manager of NGINX, for this fascinating discussion.
Thanks, Bruce.
Yeah, thank you.
Pleasure.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.